Today we will going to explore the global comparison of a DRI, HBI and scrap, that is direct reduced iron, hot briquette iron and scrap, focusing on their production, cost, quality, energy use and market trend as of 2025. So this discussion is highly relevant for understanding the evolving steel industry landscape and planning our raw material strategy. This slide compares the current price. In India, DRI cost about 25,000 per ton, while imported HBI offers are slightly lower, around we can say 275 US dollar per ton, CFR Kandla. Uh, Scrap, however, is significantly higher at the nearly 360 US dollar per ton globally, and this is around 30,000 rupees per ton. So globally, DRI and HBI range between 280 to 360 US dollars depending on the region and the process. So the key point is scrap carries a premium over DRI mainly due to international supply chain issues and its higher quality requirements. Now, coming to our very important data containing slide, that is about the tabulated cost and the price data. Here we see the detailed number in both USD and Indian rupees. So notice how Indian DRI benefit from the cheaper local iron ore, which is about 70 to 85 US dollars per ton compared to the global benchmark of 96 to 110 US dollar. But the risk lies in gas prices and the currency fluctuation, which can directly affect the competitiveness of the DRI and HBI imports. Now coming to the our next slide, which is also about the classification of the DRI types, and especially lump DRI is very common in India from the rotary kiln, while the pellet DRI dominate globally with the higher purity. Fine DRI is a byproduct, usually lower price. HBI being the dense and easy to ship, and especially where we have got a export sort of things are there, our oxidation issues of DRI is there, and to contain more metallic content with some accommodational constraint, the HBI is more preferred component. So coming to the gas-based DRI, which are produced from the Midrex or HYL, represent the majority of global production, while coal-based DRI, through the cheaper, comes from higher emission and remains India's backbone. Now coming to the quality comparison is also very important, and in this part we can say that our difference in the quality becomes very clear about the DRI and HBI. And as we know that DRI and HBI are the high in purity with the low residual elements and making them ideal for EAF steel production, and they are basically a premium grade. And scrap in coastal has a variable quality with a higher residuals, which limits its use in certain high spec steels unless it's deeply processed or blended with the DRI or HBI. So coming to our biggest producers and the regional breakdown slide, here we can say that the globally India leads DRI production with over 43 million tons. It's a big value, followed by Iran, Russia, and Egypt and Mexico. Now the HBI production is concentrated in Russia, the USA, Venezuela, and a few MENA countries. For scrap, the US and EU, and particularly Turkey and Japan, remains the biggest importer and exporters. So this shows a clear geographic split between DRI, HBI and scrap dominance. Now coming to our energy consumption part, there we can see that the energy consumption is a major differentiator. Gas-based DRI require around 11 to 12 gigajoule per ton of steel, while coal-based DRI is much higher, up to around 21 gigajoule with a heavier CO2 emission. So hydrogen-based DRI is emerging as a very cleaner route, though still pilot scale needing around 50 to 80 kg of hydrogen per ton. By contrast, the scrap EAF route is most energy efficient, as we have come across the entire slide and information, requiring which about 3.5 to 4 gigajoule and mostly electrical energy. Now coming to the our emission part, which is also very important, and looking at the emission, if you see the DRI-EF route emit around 1.9 tons of CO2 per ton of steel, while the scrap EF route is much lower at zero point 0.4 to zero point 0.7 tons. In terms of energy sources, DRI HBI relies heavily on the reducing gas, about 60 to 75% of the total energy input, whereas scrap depends fully on electricity. So we come across this electricity component is very important. Now coming to the iron ore and energy source split that we have seen and we have discussed. Now coming to the iron ore and its global prices and its trends. So iron ore remains in the 96 to 110 per ton of range globally, that is in US dollars, with India enjoying a lower cost advantage at 70 to 85 only. However, natural gas price spikes, particularly in US and EU, strongly affect the DR and HBI competitiveness. So that's why the MENA and India, with access to relatively cheaper gas, maintain a cost advantage. Otherwise, at this fluctuating price or a price at par is not that viable. HBI prices continues to swing between 280 to 360, as we have already discussed in the beginning of the presentation, depending on the ore and the energy cost. So this all about the price trends, and coming to the summary, we can say that DRI and HBI adoption is increasing worldwide, as we know, and everywhere a lot of companies are presenting, compiling the reports and presenting to the iron steel makers regarding this. And as the steel makers moves towards a low carbon solution, definitely these all reports are going to pay a lot. And as we also know that from this presentation, scrap is facing a supply constraint and raising premiums, especially in Asia, and this is pushing many countries to increase DRI HBI uses due to this scrap shortage. And that is also one more challenge that we have already discussed in this presentation about the quality of scrap. The quality and the energy efficiency and decarbonization goals, as we know, it's going to be very challenging in future. So we must have to reshape our raw material strategy, and in view of this, we can say that the way forward is is very clear. Producers must invest in natural gas efficient and hydrogen ready DRI HBA plant to ensure long term sustainability, especially in Asia, Europe, and MENA. And scrap importers need to look at blending strategy with DRI and HBI to offset cost and quality issue. At the same time, close monitoring of iron ore and gas trend is crucial for viability. For India, the opportunity is to remain the leader in DRI volumes while ensuring stable supplies of ore and gas. So, in conclusion, we can say that the DRI and HB are becoming central to the future of sustainability in steel making, while scrap remains a valuable but increasingly costly raw material. So the right mix of this input will decide competitiveness, cost, and our carbon footprint in the years to come ahead. So there is a very careful evaluation is required to be done, and based on that only the our strategy will be successful or fail. It depends on how well exercise is being done.